Okay. Um, if I remember correctly, my chapter 6.7 thus didn't have too many word questions as a practice. So I'm going to go ahead and try that. If you take a look at your textbook, page 408 and 409, numbers 11 and 12 are decent word questions that try to apply geometric series questions. So the practice is to be able to read the question and try to recognize where the equation comes from, what the ratio is, how to apply the formula itself, and of course, finally answer the question. So if we are to approach this without further ado, in a lottery, forgive the spelling error, the first ticket drawn wins a prize of 25. First ticket being the key word. So how about we highlight that? Okay, the first ticket is $25. Each ticket drawn afterwards receives a prize that is twice the value of the preceding prizes. How many prizes can be given out if the total amount of prize money is 2 million? So let's pretend you really don't know where to start. The first thing you want to do is identify the pattern. If term one, so let's do T1, is going to be $25, right? The next number that's going to win is going to be twice that. That'll be 50. So keep following that pattern until you see a sequence that makes sense. The next one will be 100. The next one will be a 200. And you might notice that the number is starting to grow quite big, quite fast, because this is just another way of writing an exponential sequence. Now, I want to know how many prizes can be given out if the total amount of prize money is 2 million. So the pot is 2 million. I need to actually add this up and see how large this becomes. And if the sum gets bigger than 2 million, well, I need to stop because I don't have that much money. That's the goal. So T1, T2, T3, T4, T5, I want to know what term number this is going to be when I approach basically a maximum of 2 million. Okay, so let's try to erase this a little bit. Oh boy, I can't do that. Let's try to erase this a little bit. I think from doing this diagram, you automatically see a lot of valuable information. Like the ratio is 2 and the starting value is 25. I don't know what my n is, right? But let's try it. I know that the sum is going to be at least 2 million. So Sn is equal to A R n minus 1 over R minus 1. Let's plug in what we do know. That is 2 million, approximately, right, is going to be the starting value of 25 multiplied by 2 to the power of n minus 1 over 2 minus 1, which is just 1, right? I'm not going to write that because that's a waste of our time. And that's the formula. And it might look very, very familiar. I'm going to divide by both sides by 25. And if I do that, 2,040,000. You know what? I'm not gonna trust my head since we're making a video. 2 million divided by 25 is 80,000. Wow. See, embarrassing myself in front of the camera. 80,000. Oof, rough days. From here, I'm gonna add both sides by 1. Essentially, what I'm looking for is an exponent that gets me an n value of 1. An exponent that gives me a value of 80,000. Again, in the grade 11 level, we would not have done logarithms just yet. If you know it, great. But using trial and error to, I don't know, let's force the issue. 13, 14, 15, 16, 17. So if you try 16, it should be approximately 65536. If you try 17, it should be 131072. So essentially, if I go from n value of 16 to 17, I grow past 80,000, which means I would grow past 2 million. And so we would be able to give out 16 prizes before we run out of money. And that's how we solve it. Okay. We're going to do the next one here, and I am going to try to keep it simple by erasing everything. And let's retype it in. This is textbook question 409, number 12. A bouncy ball bounces 2/3 of its previous height when dropped on a hard surface. Suppose the ball is dropped from 20 meters. So I see the sequence already. The question asks, what height will the ball bounce back after 6 bounces? The first term, the height is going to be 20 meters. The second term, I don't know what that is, but I do know that it bounces back up to a max height of 2/3 the original. That's going to be about 40/3, which is 13.33. Term number 3 would be 20 times 2/3, so 13.333. And then it bounces back up this much again. So that would be 80/6, which is, I don't know, 1 something. Anyways. Oh, that's not 13 points, that's 16 points. Anyway. Again, I am terrible with my mental math right now. So if I keep going, I'll probably be able to figure out what the final answer is. However, let's apply this in terms of a geometric sequence. So the question is not actually asking for the sum. I just actually want what T6 is after 6 bounces. Forgive me, T7, because 1 bounce would give me this, 2 bounces would give me this, 3 bounces, 4, 5, 6 bounces will give me term 7. So the n value is actually 7. Here we go. T7 is going to be a r n minus 1. My starting value is a 20. My ratio is a 2/3. And my n minus 1, that's a 6. I have to plug this into the calculator. 64 times 20, 1,280 divided by 3 to the power, oh my goodness, 3 to the power of 6, please. 729. Sort of difficult to get an idea of how high that is without doing a calculator. 1.7558, so approximately 1.8 meters off the ground when I'm bouncing it from 20 meters high. Part B gets interesting because it's trying to get you to think past just the regular or geometric series. What's the total distance traveled by the ball after 6 bounces? So to give you a visual of, you can't just actually plug it into the formula like this. Yeah, let me tell you why. If we're talking about the total distance traveled, the first distance is 20. And the second distance here shows that it is, well, it is 13.333. Okay. It shows that I traveled back up 13.3 before I fell again 13.3, right? And then the next one, 80 divided by 6, 60, sorry. 9. What am I doing? 80 divided by 9. I would jump up 8.88 and then go back down 8.88. And then from there, I would have gone up 5.93 and gone back down 5.93. So if we were to simply do a geometric series, it would be 20 plus 13 plus 8.8 plus 5.8, and then all the down arrows are what we'll be adding. But once we do that, you need to also consider there is another geometric series that I need to add up all the up arrows 6 times, right? What is the total distance traveled by the ball after 6 bounces? So how about I clear this up and we draw a better idea, a better picture, so we can figure out an equation for it. Okay, so we have after 1 bounce, that's a 20, 13.3, and then down 13.3. Okay, and then this is the second bounce, 8. 8.89, and then down 8.89. So that's 1 bounce, 2 bounce, 3 bounce. This is the 4th bounce, and then 5th bounce, and then 6th bounce. I stop at an up arrow. Okay, so 18.8, and then 5.93, 5.93, and then another 5.93. 3.95, and then another 3.95, and then a 2.63, and then another 2.63, and then an up arrow of 1.7558, so 1.76. No down arrow. Let's take a look at what's up and what's down. Let's look at just the down arrows. We have 20, 13, 8.8, 5.9, 3.95, and 2.6. How many red arrows downwards are there? There's 6. What's my starting value? 20. And what's the ratio? 2.3. So we can actually add this as a sum of 6 terms being 20 ratio 6 minus 1 divided by 2 over 3 minus 1. And I'll figure that in a second. At the same time, we have to consider the up arrows. That's up. This is up. That is up. That is up. That is up. And that is up. Okay, consider it. This one, there's 6 blue arrows. But what's my starting value this time? It's a 13.3. And my ratio, of course, is still 2 over 3. So the sum of this up arrows is 13.3 plus times 2 over 3 to the power of 6 minus 1 over 2 over 3 minus 1. If I were to figure both of these up, minus 1 times 20 divided by the first red arrow would give me a total of 53.73. And the blue would give me, let's see, 2 over 3 to the power of 6 minus 1 multiplied by 13.3. Divided by negative 36.488, something like that, 489. So the total sum would be approximately 90.22, let's say. Yeah, 2. That would be the total distance covered. So there's a reason why this is considered a chapter question. Think about this again. If there are any questions, then you can always try to ask. Okay. Hope this video helped, and study hard.